Hello friends, as you have discussed about natural vibration in the last sessions, in that we have discussed that what is the definition of natural vibration and who started this natural vibration, as well as what are the different components related to the natural vibration. Today we are just going to see that how you can calculate the natural frequency of natural vibration and how you can solve the problems or numericals related with the natural vibration. So before going to detail of this natural vibration, first of all you have to understand the principle of D'Alembert's. So the third D'Alembert's principle said that if you will add all the external forces in the direction of inertia forces, which is equals to 0, means if you will sum up all the external forces in the direction of inertia forces, then the sum will be equals to 0. And you all know that this inertia is a property of resistance, so it is applied in the opposite direction of displacement. Suppose if you are applying your displacement in the upward direction, okay, and then your inertia will be in the downward direction. Okay, then if you will see the calculation which we have done in the last session or last video, that if your displacement is going in this direction, upward direction, then direction of displacement is this, okay, and opposite to this direction of displacement you will get your inertia force. So then you will apply the Newton's second law, or I will say apply the principle of D'Alembert's, then you will get the value of MA, which is mx double dot plus sx is equals to 0. Okay, similarly if you will call this in the form of mathematical term, then you will get that this m into d2x by dt2 means differentiation of displacement with respect to time for the two times plus sx is equals to 0. Then if this d2x by dt2, if we will write it as mx double dot, then you will get x double dot plus s by m into x is equals to 0. Okay, where your s by m is the square root of your angular velocity, or I will say natural frequency. Okay, this s by m will be equals to, means your natural frequency will be, or your natural frequency, and that will be in angular part, which is radian per second, will be equals to under root of sm, means this s by m is equals to nothing but omega n square. Okay, and this displacement is of second order differential equation, so solution of it can predict the nature of vibration. If you will get the solution of this equation, then you will definitely know the nature of the vibration, how it will move. And the solution of this equation will be equals to x is equals to r sine under root s by m t plus phi. Okay, since this solution has some harmonic function which is sine theta, so this will definitely produce a vibration. Okay, means if harmonicity will be there, then definitely it will produce some kind of vibration. And these vibrations are in the waveform to and fro motion about the mean and have the frequency of equals to under root s by m, and this is your natural frequency by default. And if you want to calculate the time period, then that will be equals to 2 pi by omega n. Similarly, if you want to calculate the value of natural frequency, then you can go with the value of n, which is linear natural frequency, which is equals to inverse of time period, and this will be in the form, in the unit of hertz. Okay, so with the help of these formula you can calculate the basic parameters or natural frequency, time period, and natural frequency in linear terms you can calculate. Okay, now let's see, this is a function which is this is n and m. Now as you know this equation, standard equation of vibration, just note it down somewhere. X is equals to r sine under root s by m t plus phi, where vibration with the frequency of omega n are going on. So you can see in the picture that this is the waveform which is going to be replicated for n number of times. Okay, now here what you have to do, you have to calculate the value of r and phi. Okay, because this is fixed, s by m will be fixed and t is variable term, so you can calculate the value of r and phi, amplitude constant and phi. Okay, so these are the two constants which you can calculate here. Okay, first of all let's see what is the initial condition. Suppose initial condition means t is equals to 0 at a time 0, then you will get the value of x is equals to xi and x dot is equals to 0. So these means this r and phi basically depends on initial conditions. So it depends on your initial. I will explain one here, rest you will discuss in the upcoming sessions. First is, if time t is equals to 0, then what you have to do? Then your x, or first you pull the block, then release the block at that moment t equal to 0. जब आपने release किया है, whenever you have released that time t is equals to 0, then start vibration after that moment. Means at initial time your displacement is xi, means somehow you have given this much of displacement, and x dot, which is your if you will say velocity, you are not giving any kind of velocity at a time of 0. So this is your initial condition, and if you will put t equal to 0 here, okay, and x is equals to xi and x dot is equals to 0, means first equation you have to put x equal to 0, then you will get one equation. After that you have to differentiate it, then you will get x dot, and then at that time you have to put x dot equal to 0 and t equal to 0, then you will get another equation. You will have two equations and you have two unknowns, which are r and phi. You can easily calculate this term. Okay. Similarly, you can calculate other initial conditions as well. Suppose first you apply the force to the block, means you have given some kind of velocity, okay, and at that moment t equal to 0, and start the vibration, and means you are not giving any kind of displacement, but you have given some kind of velocity. Okay, with the help of that also you will get two equations and two unknown r and phi. You can calculate. Third is, you have also given the displacement as well as some velocity, or I will say some kind of force. Then also you can calculate the value of r and phi, which is the two constant of this equation. So these are the parameters you will get in your university exams. Very frequently one question has been asked related to this term, that calculate the value of constant on the basis of initial conditions, and this equation will be same, means this standard equation will be same. Okay, so I am stopping here as of now. I will come with the next topic of this mechanical vibration in few upcoming sessions. So stay tuned with this particular topic. Thank you so much for your patience hearing, and do subscribe our Engineering College Banswara YouTube channel for more such update about different branches of engineering like computer science, mechanical, electrical, civil. Thank you so much.